And gentlemen, let's move on to runway traffic patterns. Before I get you to the runway diagram of traffic pattern, I want to bring your attention to this on the sectional aeronautical chart under airport data. There are a couple of things that at a glance I haven't seen it coming on any questions, but now you see over here you see this 285, that is the elevation in feet of the airport, and this L in between is the lighting. If lighting is not 24 hours, there may be asterisks over there, and this 72 to the right of that is the length of runway in feet. So those I haven't seen them on the test, but are good information to have. And main point I want to bring from this info area is I want you to note this is marked RP. Generally, the traffic pattern is in any airport is left hand. The default traffic pattern is left hand traffic pattern. But if it is right hand traffic pattern for any of the runways, you have RP over here, and the runways are marked. And these are the two runways that are having right traffic pattern, that is runway 23 and runway 34. Now, having said that, how do we find out the identifications of runways? Let me show you another image for that. Yes, on this definite question on runway traffic patterns, firstly, how do we identify the runway? At the end of the runway, the direction is marked over there. 27 represents 270 degrees. That 270 degrees is when you come to when the plane comes to land, it's heading 270 degrees. Not when you keep a compass right in the middle of the runway. The direction on this end, direction to this end is showing 270 degrees. But when you're coming into land, you are heading 270 degrees. So that is important on this question because unless you get that, you don't. To put it in this way, you have to know that to properly orientate the runway. So that's a very important thing. Let me show you the other diagram. So there you are. This is the traffic pattern of default runway. So there are these nomenclature that you should be very familiar with. You got downwind, you got crosswind, you got base and final. Most likely the question would be an aircraft is coming downwind and you are operating your drone. How exactly do you know where this airport is in relevance to the runway? So then, of course, the main thing is you have once you know the identification of the runway, then you can orientate the runway where it is heading, and with that you would be able to judge where the aircraft is. That's how you handle this question. In other words, in the question itself, it will show which runway. So, for example, if we take this runway over here in the Panda runway, if it might either say this is more like north and northwest. It could be the runway marked northwest, or if it used the other way, the land, it could be heading southeast. But the question will say that unless because from this marking you would not know which way the traffic pattern going to be, because it can change with the wind direction. So you don't have to worry that part about it. But once you orientate that, you should know where the downwind is, and then you locate the plane aircraft that way. Yeah, because the question would be something like, while monitoring Cooperstown Common Traffic Advisory Frequency, you hear an aircraft announce that they are midfield left downwind to runway 13. So generally it gives the runway identification. And the question would be, where would the aircraft be relative to the runway? So let's look at this over here. Here's the Cooperstown airstrip. Okay, this is as you see, if it's marked runway 13, means when it comes to land, it's heading 130 degrees. It's like southeast. So if the plane is downwind, it should be over here. That means it's in the east, because the plane would come downwind, go around, and go to the base and do finals and land in that direction. So it's the answer is east of the tower or east of the runway. Yeah, also, ladies and gentlemen, as I said before, I took the aircraft data portion from the sectional aeronautical chart and made on the figures. It's the figure number 20, module 8, figure number 20. I took out the list of abbreviations over here. In fact, out of the test questions, we have been seeing continuously, we have been seeing these with the dark background C, that is the Common Traffic Advisory Frequency, CTAF. But even these other things, no harm just going through as your knowledge to improve your knowledge base. As you agree, it's always better to be prepared that there could be questions that were not given at all. So I would definitely suggest to know these abbreviations also. Yeah, ladies and gentlemen, I need to take you back to sectional aeronautical charts. You see this under miscellaneous, you see all these glider signs, various gliders, ultralight activity, hang glider activity, glide operations, and unmanned aircraft activity, and of course the parachuting, and also this cute little flag is very important. That indicates for manned aircraft pilots that there is a landmark around there. So the pilots, regular pilots, will be looking for this, and FAA gives you this extra warning. There may be more aircraft traffic in that area. So as remote pilots, we have to be alert with that. And then I would like to get your attention on these obstructions. See, you have this inverted Y and multiple inverted Ys. So here, an obstruction with the height more than 1,000 feet is marked with the inverted Y, and if it is multiple, it doubles out over here. And for any obstruction less than 1,000 feet is an inverted V. If it is multiple, if it's like a M letter, and if it is guy wires, you got the that symbol also. But here, these numbers, I want you to pay your close attention on that. On the top one, the numbers are little slanted. You got 2049. It says elevation above mean sea level on the slanted one, and within parentheses you get 1149. That is that is height above ground. That is AGL. And there's also this arrow is not quite aligned and misleading, but you would figure that out, that if you have the marking UC, it is the structure is under construction. And also, folks, I would bring your attention to this area on the sectional aeronautical chart, that's radio aid and navigation. These symbols, it's good to know, but in fact the all these navigation aids are going to be navigation aid going to be replaced by ADS-B, but it's good to know. First symbol is VHF Omni Range, then VOR TAC, and VOR DME, and non-directional. This is the symbol for non-directional, and also another symbol for NDB DME. Those, of course, good to know, but as I said, will be phased out as time goes on. In fact, ADS, that is automatic dependent surveillance. That's the satellite-based navigation aid. We dealt with that in our module 4 in a lengthy manner. So once again, friends, on the sectional aeronautical chart, mainly we are dealing with two colors. Thick blue line for class B airspace, thick magenta line for class C airspace. And also, if you want to, you should notice this is not that much apply that much for remote pilots, but just for your knowledge, within parentheses it says mode C, and it says C FAR FAR 91.215/AIM. FAR, as you know, is Federal Aviation Regulations, and AIM is Aeronautical Information Manual. That mode C relates to for the manned aircraft, the transponders that to enter a certain area, it's 30 nautical miles area. It should have the aircraft should be equipped with transponders. So although it's on the same color, sometimes they overlap, but that's not a main concern for remote pilots. And then you got the segmented blue line for class D airspace, and also we have to have the special attention to this box of segmented blue, and inside you have is the elevation. It says ceiling of class D airspace in hundreds of feet, and there would be a minus sign if it falls into another classified airspace. That means it would be a minus sign, meaning 39.999, and does not go to 4,000 feet. and segmented magenta line is class E airspace to surface, and faded magenta is class E airspace to with the flow of 700 feet, and faded blue is class E airspace with flow of 1200 feet. Those are important things to remember, and will need to know when you do your charts or maps. It will come into your attention over and over again. And one other thing I would like to show, let's make sure this IR211 or it could be VR211. They are military lines. See, it's marked MTR, military training routes. So that you have to be aware of also. And you should not get it mixed up with the V lines or Victor lines like V69 over here. Because these are when manned pilots plan their route. They plan the route between the two nav aids. Then that's what is marked as V lines or victory lines. Yeah, friends, at this point I should tell you I'm getting closer and closer to my pledge. You cannot fail this even if you want to. So let's keep going. Okay, folks, let's do the maths. Scary once again, right? I took out the worst one to scare you. Oh no, not really. I just want to bring to your attention what I was talking about, the IR lines or VR lines, which are military training lines. In fact, I got that question, so you should be really ready for this. Look at this. Do you see these VR lines? Yeah, those are all military lines. So then, having said that, let's do a little more on these charts. Oh yes, most of what we were talking about just a while ago, I can show you over here. See this letter C with the thick magenta background. That's the common traffic advisory frequency. See, along with C, you got the frequency 112.8. So that's pretty much, ladies and gentlemen, a sure question. They would tell the airport, and for you to find at airport and the map number, and or they might give the coordinates. We will deal with the coordinates now, and for you to find the frequency. And look at this. I can show you the parachute over here, and again, that's another symbol to go by. Okay, so we got the C with the background common traffic advisory frequency, and then we got a glider over here that takes care of that. Wow, we got everything on this map itself. We got the parachute over here, and this all important flag, the ultra important flag. Yeah, that's where visual pilots would be looking for that landmark, and then FAA, for a very good reason, wants to alert us. And there will be a lot of manned aircraft traffic over there. Okay, friends, let's do some latitude and longitude or coordinates and locate objects, or when an object is given, we can find the coordinates. Let's do it in a very simple manner, without getting into a confusion over here. As we discussed, 1 degree is 60 minutes, and see, they are marked over here. The bigger marking is the tenths of minutes, and one quadrant is 1/4 of a degree. Like here to here, there is one quadrant. So let's see now. Over here is the latitude of 44, and then if we want to see the coordinates of this tower over here, the best way to do is on the latitude. It's not over here, it's 44. So let's try to make it 10 minutes less. That means 43 and 50 minutes on that is on the latitude, and the longitude is 100 runs over here, and this way it increases. So 100 degrees and 10 minutes, 20 minutes, 30 minutes, 40 minutes, and yeah, you can say 50 minutes. Yeah, so 100 degrees and 50 minutes longitude, and latitude is for 43 minutes and 50 something 43 degrees and 50 something minutes. So as I said, isn't that really difficult? No, as a matter of fact, when you do it, it would be like kids play. And that's but what is needed is continuously locate objects, and continuously when at least continuously locate objects when coordinates are given, and vice versa when look at an object and try to measure the coordinates. So both ways, once you keep doing that, believe me, as I say, it's going to be easy for you. Okay, ladies and gentlemen, let's do a little bit of a calculation on the elevation. Yes, as you keep looking at these maps, then you see the maximum elevation marked in two what do you call letter levels or the type sizes. So one figure is big and the other figure is small, and as you know by now, there you on the elevations, when it's marked like this, you drop off 2 zeros. So let's say obstacle is has MSL 3450, and then that's a man-made obstacle, and possible vertical error, you add another 100 for that, and obstacle allowance another 200, and then that will come to 3750, and you round it up for the next 100 feet, make it 3800, and note how you put it as I explained just now. 3 is in bigger typeset, and 8 is in a smaller type point. Okay folks, I think we are now ready to do our recap and wind down this whole module. I'm going to show these PLT codes that's on figure 8, yes, module 8 figure 19. You can see all these codes. As I said, we removed for regular pilots it's over 600 codes. We removed a lot of them and made it like 50 something codes for remote pilots.